Hi everyone, welcome to Xcoding with Alvian. In this video, we're going to add native Linux support to the previous Swift ChatGPT API that we have created. And also in this video, we're going to build a simple Swift ChatGPT CLI app that we can run from terminal. And in this video, this is a special episode. We are going to basically code using Steam Deck, which is a handheld PC, handheld gaming console created by Valve Corporation. It is a handheld PC that runs Arc-based Linux OS. And without further ado, let me show you this CLI app. So we have this user prompt. Let me ask, what is ChatGPT? Okay, waiting for the stream of response. Okay, that's the response. ChatGPT is a conversational AI model. Nice. Show me Dijkstra in Swift. Okay. Okay, here's the implementation. Nice. So this is a stream of message. We are using the HTTP stream API provided by the OpenAI. Okay, so that's the demo of the Swift ChatGPT API running inside a CLI app. All of them running natively on the Linux OS. Okay, let me exit. And then first, let's just begin by giving you a bit of context. In the previous ChatGPT Swift API, I also create this ChatGPT Swift API SPM, so which you can also depend. And when I release this, initially it doesn't support Swift, right? So the previous version 1.0. So this is the using the official API GPT 3.5.turbo, but as you can see, it's still not supporting Linux, right? So this stack will be the starting point, and if you want to use the version that support Linux, you can use this 1.1.0 tag. Okay, but for now, let's use this 1.0.0 for the starting point to add the Linux support. The first thing that we are going to do is just to copy the link address from this download zip. We're going to download this project to our machine. And let me open my console. And as you know that Steam Deck is using SteamOS, which is basically Valve Linux OS based on the Arch Linux. And I think Apple doesn't provide support for the Arch Linux. It's only supporting, I think, Ubuntu and the Amazon Linux CentOS. You can add Arch Linux support. You can install Swift actually in the Arch Linux, but in this case, I'm just going to use Docker using DistroBox and Podman. Okay, this actually use the Docker under the hood to run the Ubuntu container. Okay, so I'm just going to use DistroBox, enter, and I have created the Ubuntu 22.04. Okay, so I'm now in the Ubuntu 22.04. Now let me go to the developer folder where I will create the project. First one, we are going to use wget to download the repository. Okay, let me paste the repository. Okay, it is saved to the 1.0.0 zip in this folder. Now I'm going to type unzip 1.0.0.zip. Okay, now it is unzipped to the ChatGPT Swift 1.0. Okay, so I'm going to navigate there. Okay, now I'm this folder. I'm going to open Visual Studio Code. We are going to use Visual Studio Code. The first thing that you need to make sure is you need to install the Swift extension. This will give you the code compilation in the Visual Studio Code. Use this official one from the Swift server workgroup. Okay, and also you can use LLDB to debug program using this as well. After you have installed this, then now let's begin by navigating to the ChatGPT API.swift. Now let me open the terminal in here, and let me build the project. Okay, so obviously this will fail, right? Why? Let me show you, right? There are several compilation errors. First one is the URL request, URL session cannot be found in here, right? These types. Because on Linux, actually the URL session requests are provided from the foundation networking instead of the just foundation, okay? And also, even if we import foundation networking and able to access the URL session, URL request, there are other problems, right? If you see in here, the URL session.batch, this is for downloading stream of data using async await, and this URL session.data for downloading the full response using async await as well. These two APIs haven't been implemented in the Linux platform. Okay, so we cannot use those two. The biggest issue is this async stream, right? We want to be able to stream the response of text from the ChatGPT. For this, maybe we can use the old implementation, closure-based implementation, and use the continuation. But for this, it won't be able to do that, right? Because this is returning a stream of HTTP response. So to mitigate this issue on Linux, we are going to basically use this SPM as well, async HTTP client. So this is built on top of Swift Neo, which is Apple official server client event-driven framework. It's a very performant one, and it provides a first-class support for Swift concurrency, asynchronous and non-blocking request methods, streaming body download. This is the most important thing, right? We want to be able to receive the stream of HTTP response from the OpenAI. So we are going to use this basically only on Linux. Okay, what I mean by only on Linux, basically these dependencies will only be linked to our product when it is built under the Linux platform. Okay, let me show you what I mean now. First one is, let's copy this and navigate to the Visual Studio Code, go to the package.swift and go to this array of dependencies and then paste this. Okay, this will add the dependencies, and then we need to add the dependencies for the ChatGPT Swift target. Let's copy this product, paste. Let me add a closing parenthesis. Okay, so one of the thing that we are going to add in here, right, which is the condition, and this basically accepts when platforms, right, we're going to use this. It accepts an array of platform. So for the platform, we are going to pass Linux. Okay. What this means is basically only when this ChatGPT Swift built on Linux, only in this case, this async HTTP client will be linked. Okay. Otherwise, on the Darwin platform, such as iOS, macOS, tvOS, and watchOS, it won't be linked. Okay, so the binary won't include this async HTTP client on the Darwin platform, but it will still try to resolve this package even if you run it in the Darwin platform, or which is Xcode. Okay, but it won't be linked and included in the binary. That's basically what it will do. Okay, so now we have added the async HTTP client, and then add this condition when the platform is Linux. Only in that case we will link. Next one is make sure to run Swift package update. This will make sure to resolve the dependencies, download the dependencies, which is Swift Neo and the async HTTP client. Next one, navigate to the ChatGPT API.swift, and here we are going to add several. Let me close the terminal first. We're going to use a conditional compilation macro, and in this case, if the OS is Linux, and if, okay, in this case, I'm going to import async HTTP client And the next one, I'm going to import Neo Foundation Compat. Okay, Neo Foundation Compat will basically help us later. We will want to play around with the data type in the async HTTP client. The data type provided by the Swift Neo is different compared to the data from Foundation. It is using a byte buffer. Okay, so to help us later to bridge between byte buffer and Foundation type such as string or Foundation data, it provides this Neo Foundation Compat for us. This is basically like an extension that will help us later to bridge those data types later. Okay, because we are going to decode the data using JSON decoder, which is comes from Foundation, right? Okay, we will see that later. Now, next thing is let's build it first. Swift build. Let's make sure we build this HTTP client so it can provide code completion for us. Okay, let's wait a bit. Okay, it is completed. Now let's begin implement. What we are going to do is basically we have these two methods, right? These public methods, which is the send message stream. This is for receiving the response in our stream, HTTP response stream. And the next one is the send message. This is just the normal HTTP request and response life cycle. Okay. And basically for these two public methods, we are going to add additional conditional compilation, and we will implement a separate implementation, each for Linux and each for Darwin. Okay. So let's add if the OS is Linux, and then else, and then make sure we close with an if macro, and select these two methods. Okay, select this, cut, and put them inside the else block. Okay, nice. And also for the URL session and URL requests, we are not going to use them in the Linux platform, right? Because we are going to use the async HTTP client, which doesn't really use that URL request and URL session. Okay, that is for the Darwin platform, Apple platforms. Now let's move on to the Linux. Okay, the first thing on Linux, we are going to add a private let HTTP client, and then here we are going to initialize HTTP client, and we need to provide a event loop group provider. Okay, and then create new. So basically this event loop, you can think of that as like an event loop that manage dynamic threads, right? So it will basically manage the threads for you inside an event loop. Okay, that is our Swift Neo best things. You don't need to worry that. And next one is private var client request. So this will be a computed property, and we are going to use HTTP async HTTP client, HTTP client request type, and then inside let's declare request var request, and then initialize HTTP client request. In this case, let's pass the URL string. Let me verify one thing. So this URL string, actually in the previous implementation, we put the URL string inside this. We hard coded this, right? Let's put this out into a variable, okay, a constant, and let's pass this URL string as well. So navigate here, and then declare a private let URL string. Okay. Okay, that is the URL string constant that can be used in each on Darwin and each on Linux. Okay, we have that URL string now. Let's continue by setting the request.method. So basically we're going to send the response in the body, and we are going to use post. Okay. And next one is headers. So basically we have the headers compute property that contains the content type and the authorization. We're going to loop this, and we're going to invoke request.headers.add, and we're going to use this name and value. And for the name, we can use this key, and for value, we're just going to use the value of the element. Okay, because we basically have injected the headers to the request. And now let's just return the request. Okay, we have this. Now let's begin implementing this method first, the normal one, the one without the stream. Okay, so this is the method signature. Make sure the method signature is same between the Darwin on Linux, otherwise will give an error when client try to import them and using them on different platform. Now let's begin by implementing this. What we are going to do is basically declare a var and then invoke that client request, HTTP client request, and then we need to inject this body, and basically we need to use these bytes. Okay, and if you see, it accepts this byte buffer, right? So the type of the data between SwiftUI and Foundation is different. And in this case, as we have imported the Neo Foundation compact, we can actually pass the data to here. Okay, so let's invoke try JSON body, passing the text, and for the stream, in this case we pass false. Okay, so this will basically convert it to the byte buffer. If you see this JSON body, return the foundation data, right? Because we have imported the new foundation compact, now we're able to basically pass this as a byte buffer. Okay, now we have injected the HTTP client request body with the JSON body, okay, containing the message, the user prompt, as well as the history. Next one, let's begin by declaring a let response, and then let's invoke try await HTTP client, and then execute. Okay, in here we need to pass the client request, and we also need to pass the timeout. Let's pass a seconds of 25. Okay, this is required by this async HTTP client. Okay, now we have the response. So what we can do now is how we receive the data in async HTTP client is a bit different because of the nature of Swift Neo, right? So let's begin by declaring a var data and then initialize the data, right? This will be the empty byte array. And what we need to do is we need to use for try await buffer, okay, in response.body. So basically the response.body will contain the stream of byte buffer. Okay, so async stream of byte buffer, so we can use for try await, and then in this case we can just append, and if you see here we need to basically init the data. If you see, right, this one with buffer, right, we can pass the buffer in here. Also, this is provided by the Neo Foundation compact, but we can initialize foundation data with the Swift Neo byte buffer. Okay, now we have the foundation data. We are looping this and then appending this. So after this will be a complete data. Okay, next we need to check, right, the response dot status. In case it is okay, in case it's not okay, okay, we're going to basically throw an error. Okay, let's declare an error, which is a string bad response, and then you can just use string interpolation passing response dot status dot code. Okay, and next, in case the data dot count is larger than 0, right? And we are able to use JSON decoder to decode type of error root response.self scroll from the data. Okay, only if this is successful, and then let's access the error. We are going to append the error string with the string. Let's provide a new line and then provide string interpolation, and then we can use the error response dot message. Okay, this will contain the error message, and then finally we can throw this error. So you may be wondering, if you haven't followed the previous video, right, especially the first video, why this string can be thrown, right? Because basically we can just extend string to confirm the error, as simple as that. But I really recommend you to watch the first video where we'll build this from scratch. Okay, now we have got the error in case the response status is not 2xx. Now let's continue. Let compilation response. We have the data, right? And then try self chosen decoder dot decode, and you can pass compilation response struct type, and then pass the data. Okay, so that will give us the compilation response, and let's get the actual response text. So it's from compilation response dot choices dot first dot message dot content. Okay, this is optional, so let's just provide an empty string as the default fallback value, and then invoke append store to history list passing the tags and the response tags. Okay, and we can now return the response text. Okay, this is the Linux implementation using async HTTP client for send message. Nice, right? Next one is send message stream. Okay, this is the one that return an HTTP response stream of HTTP response, a chunk of data. Okay, let's copy the method, paste it in the Linux. Provide a closing braces, and let's implement this. So basically the implementation will mostly be the same, right? I'm going to basically just copy and paste this. Okay, let me show you what different until this guard. Okay, the end of this guard, maybe we can put those in a one method instead of copy and pasting, but for now it should be okay. Okay, one thing that we need to change, which is the stream. Okay, in this case let's pass a stream as true. Okay, this will tell OpenAI to return the response in chunk of stream. And then basically this, right, where we loop this, we will basically cut this and then put this inside this here. Only if in error we're going to loop the buffer. Okay, so this handles the error case in the send message stream. And the next one, we will basically need to return this Swift async throwing stream. Okay, this is just like the one in Darwin, still with the type of string error. This is the type, and then we need to pass the continuation closure. Okay, and then just like before, we're going to switch to async contacts using the user initiated QoS and passing weak self in. Okay, basically in here, let's just use the do try catch. In case it fail, we just going to pass continuation dot finish, passing the error. Okay, throwing the error. And in the do, right? In the do, still far, we're going to declare a response tags. We're going to keep on appending this and then yielding this to the continuation. And now we need to use for try await buffer in response body. Okay. Yes, this will be a byte buffer, Swift neo byte buffer, and we will basically declare a delete line and then initialize a string using byte buffer. Okay. Yeah, passing the buffer. This is also provided Swift Neo Foundation Compact framework extension. Okay, so it's able to basically convert a byte buffer into string. Now let's check if the line has the prefix data. Okay, so basically this will be the same, right? After this line, I'm just going to copy and paste. Okay, from the one provided we have implemented before. Because we already get the line now, a string, actual string. So the process will be same, right? We just need to check if the line string contains this data as the characters. We're going to drop it, and then we're going to basically convert it to the data, the remaining string, and then we're going to use the JSON decoder to decode this with the type of stream completion response. Okay, passing the data. After that, we're going to get the response time text from response.choices.first.delta.content. Okay, that will be same. And that's it. We have implemented the send message stream using async HTTP client for Linux. Now, for the moment of truth, we will need to build this. Make sure it's still working. It can be built successfully. Now let's type Swift build. Okay, now the build complete. It doesn't throw any compilation errors. We have added the Linux support for the ChatGPT API. Nice. Oh, one more thing before we move to the CLI app. So for the Linux platform, let's add a DE init. Okay, as you can see, this HTTP client, right? So basically, after we use that HTTP client, we need to make sure to call shutdown, right? This HTTP client shutdown, right? We have to make sure to call this before our application quits. Otherwise, it can cause any memory leak or some more error in the console. Okay, so only in Linux, add the DE init and then type self HTTP client, and it must be running on the async context. So we capture that, and then here we can invoke try await client dot shutdown. Okay, let's just make this try optional. Okay, that's the thing that we need to do on the Linux client. The init, we need to make sure to shut down this HTTP client instance, and that's it. Now let's move on to implement the CLI app for the ChatGPT. And back to the developer folder, I'm going to create a new directory. I'm going to give the name of ChatGPT CLI. Okay, I'm going to navigate to the ChatGPT CLI folder, and then in here I'm going to type Swift package. Okay, in it, this will create a new Swift package, and then we're going to pass that flag type and then pass executable. So it means this SPM is an executable SPM package. Okay, creates all the sources for us, the initial targets. Now let's open this in Visual Studio Code. First one is, let's go to the dependencies. Okay, so the first one that I want to add is adding dependencies for this ChatGPT Swift API. Okay, so now let's go to this HTTPS code and then select this and then copy this. Okay, and let's go back to the project. So in this dependencies array, let's just put this, let's create a package, and then for the URL, let's pass the URL string. Okay, this is the URL, and then we are going to pass from the version, the tag. In this case, I want to pass 1.1.0. This is the tag that contains the Linux support. Okay, next one is we need to go to this executable target. So this is the first one, ChatGPT CLI. And then here, let's add a product. For the name, let's pass ChatGPT Swift. And for the package, it's going to be the same, ChatGPT Swift as well. Okay, we're going to add these dependencies to this ChatGPT CLI target. Okay, now let's open the terminal and then let's type Swift package update to resolve all the dependencies. Okay, it's going to depend on download ChatGPT Swift, which depends on async HTTP client, which also depends on the Swift Neo. Okay, everything's already up to date. Just type Swift build first. Okay, it resolves all the dependencies. Now we can go to the sources, ChatGPT CLI.swift. Okay, this is where the main keyword is provided. So this will be the entry point of our application. First one is let's delete this. Okay. Actually, in here, let's just remove everything from the main. First one, we are going to declare a static class. But before that, let's import ChatGPT Swift. Okay. And then static class API, and then initialize ChatGPT API, and then we need to pass the API key. Okay, let me find my API key. Give me a second, right? Okay, this is my HTTP key. I'm going to pass this. Okay, obviously you won't be able to use it because I will be revoking it after when I'm publishing this video. Okay, that is the API. We don't have the API. Next, let's basically just print the introduction to the CLI app. Welcome to Swift ChatGPT CLI app. Okay, let's also provide an extra new line in here. And then first one is, let's type user prompt colon, and then let's declare a prompt. Okay, and the type is optional string, and in this case, to read the input from the user, we can use this greet line. Okay, this will accept the input and then put it into that prompt variable. And next one, let me close the terminal. After that, we're going to use this while loop. Okay, so while the prompt is not nil, right, in case the user still inputs a character, and make sure the prompt the prompt. Okay, this is let's unwrap that, and then the prompt is not empty, right? In that case, we're going to continue and then provide a new line. ChatGPT. This will be the response of ChatGPT. We're going to print that, and let's use you do catch. The catch just print the error.localized description, and in the do we will get the stream using try, await, APIs, and message stream. Okay, and then pass the prompt. Let's just unwrap that, and it will give an error because we are not in the async context, but we can simply handle this by adding this async keyword inside this main. Now this becomes the, it will be executed in the async context, this main. Okay, so we got the stream. Now we need to loop this async sequence for try, await, line in stream. Okay, let's just print the line, and then let's put a terminator so it will still continue in the same line. Okay, just pass an empty string. Otherwise, this print will basically end it with a new line. Okay, so with the terminator of empty string, it will continue the next print statement in the same line, at the same line. Next, after we complete all the sequence, looping the sequence, async sequence, let's provide a new line and double new line, and then trigger again user prompt semicolon, and we're going to make it recursive. I've been invoking prompt, assigning the prompt with read line again. Okay, so in case the user press enter without typing anything, the prompt will be nil, and then we will exit from the program. Okay, as simple as that. I think let's put the prompt in here instead of inside the do after the catch as well. Okay, yeah, this is basically a simple CLI program, ChatGPT prompting the user and providing the answer. Now let's just try this. Okay, so to try, type Swift run. Sorry, I want to close this Explorer window. Okay, there we go, the user prompt. Welcome to Swift ChatGPT CLI App. User prompt, what is state object in SwiftUI? Okay, let's wait. So there's the response. Nice, it's a stream of async sequence chunk of data. Nice. Oh, awesome. Let's test whether it's now the previous context. What is the difference between observed object? Okay, the difference between the state object and observed object, but I don't mention the state object in here. But it is able to infer the previous conversation state because, as you know, right, we put the history inside the request as well. So yeah, now if I try to enter without typing anything, it will just exit the program. That's it, the ChatGPT CLI app. And yeah, this is a native Linux application. So in this video, we have successfully created the ChatGPT Linux Swift API for Linux. So if you want to use that in your server, you want to deploy it somewhere, EC2, Google Cloud, Azure, yeah, you can use this if you want to use Swift in your server program. And also we have created a simple Swift CLI app using the Swift package executable. This is a very simple CLI, but it actually works very, very good. And that's basically for this special episode where we code not using Xcode but using Steam Deck. So that's it for this video. Like this video if you like it, subscribe if you haven't, and thanks for supporting me so far. And until the next video, goodbye.